Hello and welcome back to On the Brink. This is Nick Carter. This is Mining Mini-Series Adjacent. Today we're sitting down with Brian Venturo and Brannin McBee of CoreWeave. They've both been on the show individually in the past. Now they're together. A lot of people wanted to know what Ethereum miners thought of the merge, what that was like, what that transition was like, how they coped with that. CoreWeave used to mine Ethereum proof of work. Now they've transitioned onto other kinds of workloads in the exploding space, in particular of AI and ML, other forms of rendering and high-performance computing. It's a fascinating sector that they have found themselves in. So without further ado, here is the episode. Very special edition of the show today. Brian Venturo and Brannin McBee of CoreWeave. You've each done the show in the past, and now for the first time we have you together. So, welcome.
Excited to be here today, Nick. Thanks for bringing us back.
Thanks for having us back. You know, Brannin, did you listen to mine? I did not listen to yours.
Sounds about right.
Brannin had 2 episodes.
Brannin had 2?
Yeah.
I had two.
Come on. I didn't know about either of them, to be honest with you.
Yeah, so Brannin did one on the Texas grid, and then you've each done one on sort of like your transition from ETH mining or mining crypto to the cloud, which is the topic of today's conversation. And it's funny because each of those conversations were 1 year apart, so starting 2 years ago. And the transition is finally here. We've transitioned. You know, the merge occurred.
It's over.
Yeah. So your long, troubled journey with Ethereum, you know, real love-hate relationship has come to an end. Do you feel relieved?
Well, I think that we're all relieved that we never have to talk about proof of stake to an investor again.
Yeah.
I think that there were a lot of folks that missed the point that crypto was providing us the leverage to build a massive compute resource base, kind of on a permissionless basis, and how valuable that was to us. But are we sad to see it go? Yeah, we're sad to see it go.
Yeah, and I mean, I think it comes back in the future as well, and we can get into that, but in some form, there is going to be infrastructure demand on the blockchain, but it might not just be a bunch of people running around putting GPUs on old clothing racks in the middle of warehouses. I think it'll look something a lot more like what we operate today, which is infrastructure in tier 4 data center environments.
You know, when you have an argument with your girlfriend or spouse and she storms out and you monitor yourself like, oh, she'll be back. I feel like that is the case with Ethereum. Am I crazy to believe that? I think Ethereum is going to go back to proof of work.
I think you're a little crazy to believe that the core developers on Ethereum proper would ever go back.
They'll be back. They'll be back.
That ship has sailed. That's not to say that there's not going to be something else that looks similar to it that's not running proof of work. Right, but I mean that really has to see the market come to the conclusion that maybe proof of stake in a super centralized fashion is not the best consensus mechanism. But I think that's to be determined for sure.
I mean, the early signs are not looking promising for proof of stake. Let me tell you that. A significant percentage of blocks are already being mined by OFAC compliant entities. Or assembled. So already, there's effects.
Like before you move to proof of stake, it was a new entrance activity, right? You could have a GPU in your computer and all of a sudden you're now part of the Ethereum network. And now you have to go out and buy Ethereum to be able to stake, and you have to either join a validator pool or have enough money to be your own. And like you said, it's pretty centralized, but this is what they wanted. I guess we'll see if it was good or bad over time.
Yeah, that's right. I mean, it was a deliberate trade-off, right? You win some acceptability with the Davos crowd. You reduce the energy consumption. The cost is the big platforms which custody all the coins and will do much of the staking, they are now empowered. I think that's not a controversial thing to say. And one early data point I saw was apparently 25% of blocks post-merge are now being built with MEV boost by Flash bots, which is OFAC compliant, and then a vast majority are being relayed by Flash bots. So not necessarily being built with MEV boost, but there are a small number of entities that now have a lot of influence over block construction.
Yeah, not to mention Tornado Cash being censored as well at some of those entities. I think what you'll quickly see is a quite an amount of centralization occur within that network. Some types of transactions will be censored, and what was otherwise a decentralized, censorless network previously, and it must proof of stake must have been designed with that in mind, that was going to occur, because there's no other solution
Right.
that comes out of this, right? Like, of course it becomes more centralized, and it must have been built with that in mind. Maybe that makes it more enterprise adoptable, where more
Right.
large entities can participate in it. We'll see where it goes. I would be surprised if they just made a decision 5-6 years ago, whenever it was, and stuck to it and didn't take any new data points into account. But we'll see.
The crazy thing is that you've gone from an OFAC compliant banking system that was centralized to now an OFAC compliant decentralized banking system that also seems to be centralized among Coinbase and other validator pool providers, right? Like, that doesn't really seem very different to me.
Yeah. And the validators have these enormous returns to scale. They have regulatory barriers to entry. That's, I think the US government, various regulators have an incentive to just deal with a small number of institutions. And so it's difficult today to start a competitor to Coinbase, right? So given that, there's not a lot of churn in the set of big validators.
Yeah, but it can be done, right? And just because somebody's big doesn't mean that you can't build a competitor. I mean, we did it to compete with AWS, GCP, and Azure, and to going back to that idea of proof of work mining, like, we had something that helped us do that, right? And the idea is that the network really needs to empower people to be able to find entry to running those validators. And Ethereum in particular right now is, like, the barrier to entry is so large that unless people build their own validator pools or are able to shepherd capital, it's unlikely to happen, right?
So post-merge, some people pointed out that Ethereum Classic got a bit of uptake in terms of the mining. What are the prospects for the remainder of proof of work for the GPU mineable chains? What else is there? It doesn't look like there's a lot.
We saw that there was Ethereum Classic got probably 16% of the hash rate. Ethereum proof of work got about 4.8%. Raven coin was another one around 4% or so. But overall, about 75% of the network doesn't really have a home anymore for the way it was used previously in proof of work efforts.
And that's what we're 2 weeks after the fact now.
Yep.
So the dust is
But,
settled.
like 2 days after that, though, you probably had 65% of the network still running, trying to pile into these other chains.
Right.
Ethereum Classic had like 350 terahash at one point, right, which was all the ASICs and everybody that couldn't figure out how to mine or liquidate other coins going there. And the same thing on the smaller coins like Raven and Ergo. The race to those chains was crazy. And then in the past 2 weeks, the dust has started to settle, at least, where people have gotten kind of over their delusions of grandeur of what GPU mining was going to be after ETH. So, we hear on a daily basis, like, hey, XYZ is trying to sell like 10,000 3090s or 20,000 3080s. And it seems like it's a bloodbath out there on the consumer card side.
And that should continue to accelerate as well, because people are battling really high electricity costs also. So
Yeah.
guys running through the end of the month makes sense. maybe even through the end of the year, depending on sort of power purchase agreements that they have in place, especially for the commercial guys. But any of the at-home participants in the network will likely have moved on from here. Like that community, that huge community of at-home miners, is now gone from the Ethereum network. Some of them I'm sure moved on to staking mechanisms. As I said earlier, I think there'll be opportunities in other networks in the future. I think like Aleo will be a pretty fantastic network and will draw a lot of people to it. But today, there just aren't many profitable options. I mean, if anything, these things are pretty much losing money at this point, just considering how high global energy prices have gone in the past 6 to 12 months.
Yeah, after Ethereum mining here is done, for people that want to continue participating in crypto that own GPUs, the economically efficient thing to do now is for them to try to liquidate those GPUs and buy the crypto outright. Right, and that's like for what the returns are today. Like that's by far the best use of capital, which is putting that pressure on the GPU market. Which, you know, when there's 8 million of these things coming to market at the same time, or whatever that number is, it's in that millions magnitude. I don't think that there's going to be demand there to really satiate that supply.
Have you heard from the gamers? Have you received thank you notes or anything? Like, thanks for, releasing your grip on the GPU market?
Oh, we so we haven't bought consumer or mining GPUs since 2019. That was the last time that we bought a non-data center card. Right, so we were definitely not part of that problem, and we were combating with miners that moved into some of the data center cards to try to mine with. That caused us some supply chain issues, right? But the principal reason for us buying cards was never mining over the last 3 years. It was always, how do we use this to serve real clients, and then when they're not using them, we can mine with them as well. So thankfully, I don't think we have any misplaced hate towards us from the gamers. But I think there's people that were really angry out there for a really long time.
That didn't get talked about a lot. I mean, the flip side of the reduction in the energy consumption is potentially a lot of e-waste if those GPUs are just not economically useful anymore.
Right. I mean, the energy consumption part of it is interesting. There's definitely a few numbers floating around in the market about various estimates.
Yeah, so I think it was Justin Drake that provided this estimate of 20 basis points of global electricity consumption reduction due to the merge, and then Vitalik actually rebroadcast it, and I have issues with this number. So I looked into it, and it came from a certain Dutch central bank employee named Alex de Vries, who, if you're not familiar with his work, he is basically a climate activist masquerading as a researcher on the topic of crypto. He literally works for the Dutch central bank. It's a conflict of interest as far as I'm concerned. And he produces these numbers on Bitcoin and I guess formerly Ethereum energy consumption. They're always way too high. So yeah, that's where this number derived from. I'm told that you guys have an alternative estimate for the energy consumption of ETH pre-merge. Is that right?
Yeah, I mean, our backgrounds are in the energy space. At the end of the day, like, this is really simple math to come up with estimates, right? Like, the International Energy Agency publishes global energy consumption values. Their latest number is 2019 for estimated number of terawatt hours that were consumed in the electricity space. And I think that makes the most sense, just giving COVID, everything along those lines, right?
Yeah.
So from there, you just need to come up with an estimate of the amount of electricity consumed by the Ethereum network. And in the most conservative way possible, you use old generation GPUs, like an NVIDIA 1070. You assume that those things consumed about 70 watts at 30 megahash. So that's about 2.3 watts per megahash. Extrapolate that across the entire network hash rate, and you come to about 2.3 megawatts of demand, which would
Gigawatts, no?
Yeah, sorry. Damn it. Yeah, it is gigawatts. Yep.
I'll edit that out.
Yeah,
Please don't cut that part. I want that part in there for the record.
comes out to 2,300 megawatts of demand, which is about 20.4 terawatt hours annually. And when you relate that to that IEA estimate of 2019 electricity demand, that came in at right around 23,000 terawatt hours. Run the percentages, and that's 0.08%.
Yeah, so just over a third of the estimate being promoted by the Ethereum community. For context, if ETH was 2-ish gigawatts, Bitcoin is around 10 gigawatts.
Yeah, I think that's about right. Yeah, and you keep in context as well that like these GPUs have been repurposed to other networks as well. So at the end of the day, you assume 20% of them are going to sit on Ethereum Classic, Ravencoin, Ergo, a couple of these other networks, and then all of a sudden your actual electricity reduction from moving to proof of stake is materially less than those numbers being kind of pushed around in the market.
Yeah, so you might be looking at 6 basis points
Yep.
of electricity reduction. Yeah.
I think that's more accurate.
Yeah. So and also to support that, Kyle McDonald has an estimate of Ethereum's electricity consumption, which is virtually the same. So, I think that is a much more credible estimate than the DeVries method, which is just, it's insane that he gets cited because he really is deeply conflicted. And so then the other question is, those GPUs, what share of them do you think were repurposed in sort of like the CoreWeave model?
0.
Aside from CoreWeave.
I think that the expectation, and we've seen a lot of pitch books out there.
Page 76, Brian, to be specific, of those pitch books.
That's not of people that were going to repurpose their GPU mining operations in the clouds. And I think there are probably a couple small guys that I don't know about that have done it, or maybe are in the process of doing it. But it's not like you're flipping a switch, right? There are significant technical requirements to be able to support any type of client. This idea of clients liking or being okay with interruptible workloads, like, is a great idea in theory until you actually have a client who gets interrupted, and even though they said they were okay with it, they're very much not okay with it. And the amount of infrastructure that we've built over the past 3 years to offer the quality and scale of services that we do are astronomically larger and more complex than I expected them to be. So I think that this pie in the sky idea of like, hey, we can run distributed compute on the blockchain and be able to provide rendering or AI ML tasks, not even taking into account like the technical problems with that. I just don't think that it's really feasible to serve any type of real workload. And it's terrible to see because, like Brannin said, a lot of that stuff may become e-waste.
Yeah.
Right? And a lot of those GPUs are running really bad environments, and they're likely not going to be winding up in gamer rigs because the gamers have become pretty adept to the idea that they're not so great for them, even when adjusting for price, right? So I think that my answer of 0 may not be correct, but it's definitely not a single-digit percentage point.
And just to wrap it up on the blockchain section, what interesting use cases do you think there might be for like infrastructure providers like yourselves in future blockchains? Like, will there be another file coin, or are ZK rollups going to require like GP, like heavy workloads? Like, will the blockchain come back around and be a client of CoreWeave once again?
I hope so. Brannon's the one who's really been running down these opportunities for us and keeping relationships in the space.
Yeah, and I think a lot of those companies are making a ton of progress, and I believe that those new layer ones will be the entities who bring enterprise adoption onto the blockchain, because they are designing their blockchains to be friendly, compliant, and scalable for enterprise adoption. And at the end of the day, they're going to need infrastructure um, to run those blockchains. Again, I think someone like an Alio is a really good example of a layer one that'll launch, by Q1 of next year. That could be a pretty material infrastructure consumer, even just through their zero knowledge proof processing component. But what exists
But
today, it's really challenging to point to substantial demand.
yeah. And so the era of consumer GPU mining for proof of work, that is pretty much behind us.
I don't know if it's behind us, but it's definitely behind us in what we've known it as, right? Where you had 8 GPUs tied to a milk carton with a 2-core CPU that you bought for $40 on eBay with 4 GB of system RAM, right? Like those days are over, right? And what you may find is for networks like Filecoin, the systems that they need for the various tasks there are very different than what you see in an old GPU mining operation, right? And I think
Yeah.
as you get to these specialty use cases, there may be blockchain compute demand for it, right? But I just don't think it's going to be coming from what we would consider today to be cloud-like workloads, right? It's going to have to be something that's newly invented, um, like Alio, right? Where they're bringing that compute in to solve a problem.
So the good news is, though, that you guys clearly had line of sight on this and used the existence of Ethereum and proof of work mining to build out your fleet. And as we talked about in the last 2 episodes, anticipated this and totally diversified your revenue streams ahead of the merge.
Yeah, Brannin gets upset about this all the time because we look back at how much Ethereum we mined and what that was on a U.S. dollar basis, and the fact that we're both still working and building a business, we feel like idiots. But we always had eyes on building something that was bigger and that wasn't just crypto related. Um,
Yeah,
so
I
we're
mean,
gonna use that one as the reason why we did it and why we're not both retired.
well, it's always good to build sort of like real products and services as opposed to just doing crypto stuff. So
Yeah, we're really excited about where CoreWeave is positioned in market today, and that's as a specialized cloud focused on GPU accelerated workloads, and we're supporting some of the highest growth sectors that exist between media and entertainment, artificial intelligence, machine learning, computational chemistry, and hopefully what will be blockchain again in the future. Not to mention more nascent sectors like the metaverse or pixel streaming technologies. And at the end of the day, they all use GPU compute. They all need highly specialized infrastructure orchestration and networking components that are not really available at the generalized clouds, or certainly not to the extent that you would expect. And increasingly, this kind of compute is looking like one of the scarcest resources on the planet.
yeah, so I definitely want to drill down into this. So, I mean, first of all, like, what does it take to compete in this market for? I guess what would you call it? HPC or industrial cloud? Like, what would be the right nomenclature?
I think it's HPC is fine. I make
Yeah.
fun of Brandon for using that term all the time, though. But it's accelerated compute, right? It's anything GPU accelerated. We don't do anything beyond that. We don't have any specialized hardware devices that we build. We don't have any FPGAs for things like transcoding services. We're really around the flexibility of the GPU and the different workloads that a single GPU can go serve.
So the GPU is still the sort of hardware unit that you're focused on.
It is, right? And it's very infrequent for us to go after clients that are CPU only, right? And while we can serve them just as well, if not better, than other providers, it's just not what we've built our business around, right? And we're able to differentiate ourselves on GPU workloads because of the way that we built our infrastructure, because of our expertise running infrastructure at scale, right? The health checking that we have on GPU systems and the ability to understand what's going to cause problems or when problems are happening, how to solve those problems, is something that even the largest clouds today are behind on. right? And some of that is from growing up running 30,000 consumer GPUs in a warehouse, right? And having to understand exactly what's happening at all of them and how to recover from errors. But some of that's also in the way that we built our platform, right? We were able to make architectural decisions that were really based around this idea of like bursty use cases.
Yeah, so tell us a bit more about that, because it's clearly very different from just plugging in GPUs and running proof like Ethereum. What does it take to handle these bursty loads?
It's so the infrastructure that we built is incredibly complex, right? And it's not just networking, it's not just storage. We've built super high throughput non-blocking networks to be able to handle the intra data center bandwidth that we have, and the majority of our bandwidth is internal to our data center environments. Right, customers come here to run crazy workloads. They don't really come here to serve their websites. So the networking piece is something we've invested heavily in. That's on the kind of the physical networking side, and then we've had to build VPC networking solutions on top of that, so customers can have virtual private cloud networks that are effectively a layer 2 network that they can connect back to their on-prem environments or run their own virtual firewalls, etc. From there, you get into like the network attached storage piece, right? Which is how do you provide access to thousands and thousands of workers with a single volume, right? How do you attach that volume to all those workers? How do you get performant metadata throughput from those volumes to be able to serve all those instances, reading tons of small files? These are not trivial tasks, right? And there's a reason why there's only like 5 companies on the planet that do this stuff, right? Is because it's hard, right? And the technology investments you have to make are not de minimis. And it really goes back to the idea I said before, that I just think there's very few people or entities on the planet that really know how to build a cloud, right? Lots of folks know how to work on them, but very, very few know how to build them.
Yeah, so I guess this is an annoying question, but why is it that the large established providers of cloud compute don't just win at this, given their advantages in terms of scale, and then obviously just virtually unlimited ability to spend?
I'll offer the very simple solution, and then Brian will do more detailed. But like on an extremely high level, it's because those clouds, AWS, GCP, and Azure, are generalized. They're trying to create infrastructure for every single use case, to be able to support major companies like the Fords of the world to come onto their infrastructure and move their entire computational needs from data storage and just simple workstations into the cloud. And they do a great job of that. And that is absolutely not something that we're trying to compete with. What we identified in market was a lack of specialization. And Brian does a really good job of explaining why we excel there.
Yeah, so other clouds today, they're built around like hypervisor workloads, right? So you go to AWS and you spin up an EC2 instance, right? They're going to instantiate a hypervisor on one of their bare metal nodes. That's then going to load an operating system. That's then going to require you to set up your environment or to have a prepackaged image. The time to be able to get it, like an EC2 instance spun up, could be up to minutes, like 2 to 3 minutes. And when you're trying to respond to demand in real time, so for things like text to image generation, right? If your user base spikes and you need to serve more inference API requests, you then have to be able to go out and intelligently manage that resource base that you're serving from, right? So if you say, okay, I've got 10 more requests just came in, I don't have enough resources to serve those requests, they're going to sit in a queue until I have those resources available. Like it could be 2 to 3 minutes before those requests get served. The user loses engagement or their request times out, and all of a sudden you've lost them and they have a bad user experience. Right? So what we've built here is, our cloud is Kubernetes native, and Kubernetes is a container orchestration platform, right? And we run Kubernetes in a multi-tenant environment where all of the nodes and all the compute resources are already available for our clients to consume. And so when they schedule a workload or their inference service autoscaler says, hey, I need another replica to run, we can have that up and running within 4 seconds serving the requests. Right? It's just a considerably shorter time to serve running on infrastructure like CoreWeave. And, AWS, GCP, and Azure just aren't built that way today, right? And for folks that don't have those big engineering organizations to stand up that type of intelligent orchestration platform, right? Like they get all that stuff out of the box from us.
The HPC market, I know there's all these estimates from Gartner about markets increasing X%, but I mean, it subjectively seems to me it's exploding right now. Is that the correct characterization?
Yes. So we are running as fast as we possibly can, right? And, it feels like we're falling behind every day. The onboarding cycle for clients with us, it's kind of use case dependent, right? On the VFX side, it's longer than it is for the AI/ML side. But we can onboard a client on the AI/ML side today, and they're generating significant revenue tomorrow.
Or they're generating significant cost savings, to Brian's point, on the infrastructure orchestration and real-time response rates as well. Because at the end of the day, like those clients, to surmount the issues with spin-up times at the generalized clouds, they just have to sit within reserved instances instead. So you might, only be serving workloads 10 seconds out of 60 seconds for someone hitting an inference solution.
The space is growing kind of at an unbounded rate. And it seems like for the past 2 years, there was a lot of research done on building of open source communities, largely around the Eleuther AI group, which CoreWeave contributed compute for to train their 20B parameter model, GPT-NeoX. Coming out of that exercise, those researchers and community members are starting to build and deliver commercial products for the first time. Right? It was like there was this couple years of crazy research and people were doing things as a hobby. And then people started to find products that might actually work. Right? And now we're in this stage where everybody's recognizing like, oh shit, people are using this. We're seeing real world use cases where this actually provides economic value. And everybody and their brother is rushing out there to build on top of it, or build using these resources. Right? We saw an explosion in large language model startups to start 2022. That's folks like Cohere or Anthropic or AI21, and they're building proprietary or principal models, right, that are going to serve products for their clients, right? And whether they have the business model that they're building products directly or they're serving APIs to their clients, everybody's super, super interested in the space because of the progress that's been made. And with that and the scaling of those models and the performance of those models, the compute needs have gone up exponentially. Right? And that's just on the large language model side, which, as they're building products for that has implications for things like writing assessment or writing help or crafting blog posts or text adventure games. Right. And where we're seeing like this crazy spike in the past 2 months is really around the open sourcing of text to image generation models. Right? And this really started after OpenAI launched DALL-E 2, which was a closed source model, and you had to request access to. And when closed source models are released, I think it's kind of everybody looks at it and goes, "Wow, that'd be really cool. I'd like to have that." Until somebody goes out and recreates it. And that's really where all the creativity comes from, is when it's been recreated and open source and people can build on top of it. And I know that you've had a ton of fun with Stable Diffusion, but the amount of demand generated around the release of Stable Diffusion and Stability AI's product Dream Studio has been insane.
Yeah.
CoreWeave has been lucky enough to be working with Stability AI on that launch. But the quality of the images that this model can create is like eye-opening. It's like, wow, this is the first time I've seen AI do something that I'm like, okay, this actually has the ability to change the creative process.
Yeah, I've enjoyed playing with both the language models and more recently with the image models. I mean, I was absolutely blown away by what was achievable with Stable Diffusion in particular. And I think I'm like the number one client for Dream Studio.
I can promise you, you're very much not.
Yeah, we've generated on the order of it's like hundreds of millions of images since launch. And I think it's worth keeping in context. I mean, this is 4 or 5 weeks old now.
Yeah.
I mean, this is brand new technology that I think Emad and the Stability AI team had the foresight to release as open source, to bring the technology to everyone and immediately democratize it. I mean, it's just
And the crazy thing about democratizing this stuff is like, why would somebody open source this? And the open source community is like a crazy positive feedback loop, right? And open sourcing technology like this is going to lead to like an unmeasurable amount of impact on businesses and developers and engineers down the road, right? And when a company is starting up, the one of the things that they have to make the assessment of is like, do I like go find something that's off the shelf that already does this, or do I build my own thing? And for a small engineering team building a new product, if they decide to build their own thing instead of using an open source solution, like they're likely not going to be competitive unless they have something super differentiated, right? So for people that can leverage open source tools, right, having something like Stable Diffusion available to them allows them to extend it and to do so much more, right, and add value around it. Like they're light years ahead of somebody that would have to design that from scratch, right? And this goes back to like why is this all exploding right now? And one of the things that NVIDIA did incredibly well over the past like 6 or 7 years is they invested so heavily in their CUDA developer ecosystem, right? And they realized like, okay, like we have this hardware now, but for anybody to actually use it, like we have to go out and like build all the tools for it so they can build with it, they can port other things that they have over to it, and like they got that they really had to make it easy for everybody to use. And now that all those tools exist and all of this prior open source work has been done on top of it, right? Like they have a huge moat around their product because everybody's going to default to them because they can save hundreds, if not thousands, of engineering hours of work, right? And it's really easy to scale compute. It's really hard to scale engineering teams.
The thing that shocks me is you guys remember a couple of years ago there's a very simple model, well, not simple, but it did one thing, which was just produce images of faces and that was it. Like typically with like, was it the GAN models, GAN?
yeah, it was GAN models.
So it was, pretty low resolution images of human faces, and that's the one thing it did. And that was actually kind of shocking to people because it's like, oh no, the person I'm interacting with on social media may not be real human, and I have no way of knowing that, and we're going to be inundated in bots, etc. And then I feel like that was maybe 18 months ago or 2 years ago. Now fast forward to today with Stable Diffusion, you can basically generate any arbitrary image at all that you want at an incredible level of resolution. And of course you have to get the prompt right, but it can do human faces at a completely photorealistic level, like portrait photography style. I mean, what explains that increase in complexity? It's just so much more complex and sophisticated in such a short period of time.
I mean, from my seat, I think it's access to scale compute infrastructure to be able to do that. We consistently get demand of thousands of latest generation AI ML chipsets, and that looks pretty different than what you observed even a year ago. And I think a component of that is it is going back to my point earlier. These chipsets, specifically the A100 series, what will be the H100 series as it's released next year, they're the scarcest commodity resource that exists on the planet. Hard stop. It is sold out across every single cloud service provider that there is, and it's sold out in 2-year plus contracts.
Wow.
It's used for training these next generation models, and I think what comes with the H100 series will unlock an even more complex set of models to be built, ones that we haven't even contemplated today. To your point, I mean, the rate of acceleration of technology in this space is driven linearly by access to compute infrastructure, and that's where we've positioned ourselves as a provider of strictly this infrastructure within the market.
Yeah. So what's driven this large change in quality, right? I think that the DALI 2 launch from OpenAI showed everybody it was possible, and when people saw that, right? I mean, the ComVis department at University of Munich, right? They came out with the latent diffusion model that Stability AI then extended and built and improved, right? But like this idea of like these diffusion models, and it's so cool what it does, where it basically takes a full image and then adds noise every step of the way, and then trains the model starting from a pure noise image back to what the original image was, right? And using captions from that as the descriptors, right? They're able to create these images from pure noise, which like that's pretty mind blowing that they were able to take like these millions of images in this Leon data set and to train it to be so accurate. Um, so while folks are playing around with this stuff, and I'm sure that people are going to try it after this call, and I'm just going to plug Stability's product here, DreamStudio.ai. They're like you very quickly realize that it's not like, hey, I want to see a cow riding a bus driving down the street. And while you may get some like great initial kind of images from that, there's some art to this idea of prompt generation, right? And that speaks a little bit to like how early this stuff is that folks haven't been able to build the models to be really good at accepting simple prompts, right?
Yeah.
And they're incredibly powerful, but folks really have to learn how to use them. But the big step there was like, okay, we're going from some of the VQGAN and CLIP models that existed before this, where it was like, yeah, that kind of looks like what I thought it was going to be, to like Stable Diffusion, where it's like, oh my god, like I can't tell the difference between that and a real image.
Yeah, I will say from experience, the prompt generation is incredibly challenging. And the model does have constraints. I mean, it's by no means perfect. Like if you introduce more than sort of 2 characters into the image, it'll get confused. And it's not that good at human body parts because it's very easy to create something that breaks the illusion. And
it's not that good yet.
Yeah.
Right. And I think that there's probably going to be some features that are coming out from Stability AI in the next couple of weeks that will improve that quality and the things you talked about there. Right?
Yeah.
I think that what was released here was like, okay, this is the first step. And we see projects and companies all over the place building on top of that, and whether that's like unlimited amounts of upscaling, or it's people that are doing text to animation generations. I think that you saw Armin van Buuren did an entire music video. It was called for the song "Computers Take Over the World." Like all of it was generated via Stable Diffusion animation.
Yeah, and for listeners who actually want to give it a shot, it's quite easy, I would say, actually, even to use the model really efficiently. So my recommendation would be to use Dream Studio, get the API, and use Christian Cantrell's plugin to Photoshop to use it. And at that point, it becomes very easy to, to generate an image and then mask it or generate on different layers to do image to image, which is astounding to me personally, is to do your own like kind of crappy illustrations and then attach a prompt to it and then have the model upscale it. It also supports inpainting now. So basically you mask a certain part of the layer and then have the model fill it in with context and with the prompt. I mean, the functionality for like digital artists, just in terms of time savings and efficiency, is just unbelievable. And I've been having so much fun with it, even as not an artist. So yeah, I mean, I can't even imagine what the next version is going to look like.
I mean, the culmination of a few technology stacks here are going to get interesting pretty quickly, right? You have natural language processing models that allow a user to offer a short prompt and then for the model to fill in a paragraph's worth or more of context around it. You have text to voice models that can synthesize any kind of voice that you'd like to be represented to represent that text, and combine those two software stacks with text to image as well, and what will ultimately be text to animation, all of a sudden you have this capability to produce unique content from a simple prompt that they've never been able to do before. Like unique video content full with voice, animation, all from a simple text prompt. And the applications of it are just going to be wildly expansive. Um, we're particularly excited about it because of the infrastructure implications around it. Because as it exists today, there isn't enough infrastructure on the planet to serve this. And I wish we could say that you can go, cobble together a bunch of retail grade GPUs to serve it. But at the end of the day, this needs to be enterprise grade infrastructure within data center environments, using some of the modern technologies that we've developed at CoreWeave to orchestrate that infrastructure.
So here's a provocative question. I was just reading this White House report on like crypto mining, and it was pretty tough. I would say they don't like it, and their big worry is that it's going to consume, a large percentage of the U.S. grid energy. Whether or not that's true, that seems to be the concern. Is that okay? Well, this is a sector that's new, it's growing, and it's competing with households and an industry for energy. Now, and there's the laden with the assumption that it's sort of not a valid use of those scarce resources. Now, do you guys expect anything similar to emerge in terms of pushback from the sort of AI space? Like, okay, this industry is growing super fast. It's scooping up a ton of energy. These data centers are appearing everywhere. Is that something that you're concerned about? Is the sort of like the crypto mining critique getting transposed over to sort of like the AI ML space?
I don't think so. And when a lot of the people that have issues with crypto mining is they look at it as like it's an endless pursuit, right, or a pointless pursuit, and they don't necessarily understand like the security or the trust implications of what that proof of work mining offers. I think it would be pretty hard for somebody to make a case that became very popular that these AI models and the pursuit of AI isn't providing some type of creative benefit. And, there's going to be other societal implications that have to be discussed around that. But I don't think that the compute to serve that stuff is going to be considered or will be treated adversarially. Right? And I'm sure there's always going to be some small minority that does treat it that way. But I don't have any concern that us serving infrastructure for AI or ML services is going to be considered that way.
Yeah, I think the scale kind of really matters here as well. Going back to those numbers we used earlier on the Ethereum network, that's an implied amount of over 30 million GPUs. That's an implied amount of about 2,300 megawatts or 2.3 gigawatts of installed capacity. We're probably the fourth or fifth largest operator of GPU accelerated compute in North America, and we're about 15 megawatts in total, right? Like it's night and day difference in terms of scale, right? And then put this in comparison to Bitcoin mining, right? It's just an utter fraction, especially relative to what's being produced as well.
15 megawatts is like one small Bitcoin mine. Like you routinely have individual Bitcoin mines that are over 100 megawatts.
Yeah, and just to go further on that, like that, the number that Brannin referenced there is like the capacity of our three regions right now. That's not actually what our IT load is in those environments. Like that's what we're built to consume there, right? And while we have systems in those facilities to consume that amount of power, we're very much not consuming 15 megawatts around the clock, right? It's a fraction of that.
Because unlike crypto mining, it's not an always-on load.
Correct.
You're performing the jobs as you get them.
Yep. And different client workloads have different power profiles. And, we do a lot of portfolioing of workloads to really understand. Like lot of portfolio to understand like how power is consumed across our fleet, and we do some intelligent balancing to make sure that we're keeping workloads spread pretty evenly, so we don't overload any areas. And, there's a lot of analytics that happens there just in our scheduling layer to make sure that we're keeping that stuff balanced and understanding that stuff's going to fluctuate pretty dramatically.
Yeah, so on this same topic, actually, one thing I will give Bitcoin miners credit for is, they're definitely more interruptible, and so they can participate in these various like demand response programs, and then they're more location agnostic than most industrial loads, so they can find relatively cheap or underutilized energy and plonk themselves down there. Now on the HPC side, I feel like it's probably less imminently interruptible because if you have a big load come through, you maybe don't want to delay that, and it's less location agnostic because latency really matters. I feel like you want to be closer to the major metropolitan areas where maybe these queries are coming from. Do you think that HPC could lend itself to being A, location agnostic, and B, interruptible? Does that comport with sort of the model?
Yeah, in A, can it be location agnostic? Parts of it can, right? And the parts that can is really on the batch training or batch inference side, right, where there's no latency component to it. That's really where you're going to go for that's going to be on a cost management basis, right? It's like, where do I go find the cheapest real estate, the cheapest power, the best environment, so that we don't have to run our chillers all the time. We can run evaporative cooling and be kind of economizers in those plants. Like that's the driver there. Like, you'd always like to be as close to eyeballs as possible, even if you don't need the low latency.
Right.
For workloads that are actually serving a client or an end user, and this is specific or most specific to things like virtual desktops in the VFX space for artist workstations, where they're doing high fidelity graphics or they're doing episodic TV work inside of a virtual workstation, and they need to be able to run 4K playback, or like a pixel streaming event to serve metaverse experiences where somebody's in this real world experience in their browser and they're doing it off of the compute in our cloud, right? Like, that's where the latency really matters. Do I think that this stuff can be run on an interruptible basis? I don't, right? And I'll talk about that separately too, right? On the batch training and batch inference side, there are real costs to interrupting training workloads. And, while people run checkpoints and stuff to make sure that if things get interrupted, they don't lose all their work. These are complex, sensitive systems that it's not that easy to go from 100% power to turning everything off because you have to interrupt your entire load to turning it back on again. Like, it's just not that easy. And anybody who says it is hasn't done it.
I guess you could schedule it, around what the grid flexibility might demand.
Yeah, but the real value in that interruptibility is the panic scenarios when the grid really needs it. And it's like, hey, I need this in 10 minutes.
Yeah.
Right. And like, those scenarios, they just don't work for that type of workload. Right. And you're talking about potentially losing like hundreds of thousands of dollars of compute time because all of a sudden your provider needs to go save $10 a megawatt. Right. Like, I just don't think that people want that.
And I think it's really important to understand that, for these AIML workloads, especially, power price is roughly 10% of the cost of operating that GPU from a fully amortized basis, right? It's a fraction of it. It's like the hardware cost is where the real cost of those components come into play. So, lowering your electricity price by a few cents a kilowatt hour is really not impactful at the end of the day, and certainly not at the expense of the latency or the interruptibility that comes with that. So it's just very different than what you would see within the crypto space, I believe.
Yeah, and there's some folks that would make the argument that, like, oh, hey, if I'm doing this at a site with stranded power, it's more environmentally friendly, right? Like, our HPC, or specifically our distributed training clusters, are all built in our Las Vegas data center right now, and that's 100% renewable power.
Is that nuclear?
So it's a combination. It's run by we're a big client of a company called Switch, and they're an incredible partner of ours. They run awesome infrastructure. I would just refer you to their website to find out what that mix is. But they have an incredible commitment to environmental stewardship, right? And we've made it easy on the distributed training side to run all that stuff there. But when we get back to the real time workloads, right, and the idea of interrupting like somebody's pixel streaming session or their virtual desktop in the middle of a workday, right? Like we have hardware failures, like that happens to every cloud, and like when people get interrupted, like they get pissed. Right. And my support staff, like if we ever have issues or when we have issues, because everybody has issues, like they hate those days, right? And even the clients that said, "Oh yeah, like I'll run spot or I'll run interruptible," like nobody actually means that.
You guys have such a diverse mix of clients and use cases. I mean, I feel like you've mentioned over a dozen different types of things people use your infrastructure for. What aside from the awesome growth in the image models, what's really exciting to you right now?
So the this idea of the metaverse is like really loosely defined, right? And to me, the metaverse is really just like the rendering and delivery of real-time experiences, right? And I don't know if that's going to be for industrial simulation where you're running digital twins, or it's going to be like product configurators like you'd see on websites, or if it's actually doing immersive experiences in the browser from afar, right? There are so many different ways that can go, and I don't think any of us really know what the true direction of the metaverse is going to be, right? But when we, as an infrastructure provider, when we start thinking about like, okay, we have clients that need 1,000 concurrent users, or 10,000 concurrent users, or 100,000 concurrent users, and every single one of those users requires a discrete GPU to serve the experience, right? Like that's where I'm like, okay, like this is cool. How do we solve this problem? How do we scale to solve this problem globally, right? And back to Brandon's point before, like that infrastructure does not exist if you combine all of the clouds today.
100,000 concurrent.
Yeah, well, let's say if you get to the 500,000 concurrent user basis globally, you can't do it.
Yeah.
Across all clients and everyone building in the metaverse, like that's a pretty small number.
Yeah, that is the largest inhibitor of growth to that metaverse space. Is
really?
Just simply access to scale infrastructure, because you need one GPU per client. Maybe you can fit a couple of clients on a GPU using some of NVIDIA's technology, but at the end of the day, like that is what will stop growth, and that is why it's the scarcest compute resource on the planet.
I watched a tech demo for the other side metaverse, which I'll give them credit. It actually looked very smooth. I think they're worth thousands of concurrent users just in for the tech demo. I hate to give the ape crew credit for anything, but I think the other the sandbox and Decentraland, you never really get more than a couple hundred users on.
Yeah. So we've spoken to the group that runs the infrastructure for the Bored Ape guys, right? So it's a company called Improbable, and their history and their product history is really in running game servers, right? I think that those guys are probably like top 3 experts on the planet at doing that stuff, right? So my understanding was that was largely CPU based, right? And they relied on a lot of the processing power on the local client side, right, to be able to handle that, which I think is a lot easier and that's more proven, right? And where everybody gets freaked out about this stuff is like when you get into like, hey, this is a really high-end experience. We have to do crazy graphics rendering in real time somewhere, and we can't do it on a phone. We have to do it in the cloud, or we have to do it. It can't be on the user's device, right? That's where it gets really dicey. And I think one of the big missed narratives today is like everybody's like throwing money at these metaverse companies, right? And like with absolutely no understanding that like, hey, the physical infrastructure here is going to be the blocker. And unless you have that at scale, like no matter how much you invest in these smaller like platform developers or game developers, like if it's not there, they're going to fail. The growth of that space doesn't happen without exponential growth of the specialized clouds serving that space.
That's so interesting. I hadn't thought about the infrastructure constraint at all.
Yeah, and that's where I get super excited about that. I'm like, okay, like bring on the million users concurrently. Like we know that even to get there for one event or one experience, like this whole thing has to get a lot bigger. And then when you go from 1 million users to 10 million users, right, that's where it gets really interesting.
So for those listening and want to investigate CoreWeave and learn more about the product suite, where would you direct them?
So our website, coreweave.com, has a lot of pretty good resources about what we do and how we do it. One of the things that we do really aggressively is we make sure that our clients are getting what they need to be successful on CoreWeave. Right? So we have DevOps and engineering teams that will dig in with clients to help them understand, like, how do I run this best? How do I architecturally think about these problems? How do I solve them? Not just on CoreWeave, but kind of in a grander scheme too, right? So, I feel like as an engineer, people are never willing to click talk to sales, but after you sign up, reach out, because there's a whole team of people here that are really excited to help with interesting use cases and scaling crazy infrastructure problems. So, we're excited to hear always about new up and coming things, no matter how crazy the ideas are, and we've got the people to support it.
Awesome. Well, I think you guys are officially the number one most frequent guest on the brink. So thank you for that as well.
Always a great conversation, Nick.
Thanks for having us.